Um, Hi everyone. I recorded this video for you to sort of do a quick review of what we did before the break. Shouldn't take too long. So it's for your benefit. I really encourage you to watch this video, speed through this video, whatever you need. Okay, so let's start with the most basic. You have a population, and I just say this population is all Koreans, and so there's a population of 50 million people in Korea. And then this is the number of masks per month that people wear. So for example, I wear 10. I don't go out a lot. Maybe you wore 12 last month. So this 12 of 15 million people, and then somehow recorded. And then we were able to find the average, let's just say around 18 masks per person per month. And then we somehow also know the standard deviation, let's just say it's about 2. Remember, this is 50 million data points. So if we convert that, and let's assume that this is a normal distribution of 50 million, and then 18 being the most common number, the average number, and the middle number, and with a standard deviation of 2. So this is the most basic thing. This is like, unit 1 stuff. There is a person that just say person A, he used 20 masks last month in Korea. And then with that, we'll be able to find his z-score. We can find his percentile, right? So 20 minus 18 divided by 2 equals 1. So this person is exactly 1 standard deviation away. So what percentile is he in? So there was a probability that the z-score is greater than 1, equal to 1. And then you look up the z-table or use a calculator. You find out that it's going to be 0.84. But on the z-score table, it always counts to the left. So we do 1 minus that. So this person is in the 16th percentile. Okay. Yeah, so he's in the top 16. So he's in the 84th percentile. 84th percentile. Okay, right over here. The probability, so you randomly pick a person, the probability you picking a person out of in the 50 million people that you pick someone who wore 20 masks or more would be 16%. This is the basic. All right, now let's go to chapter 5 stuff. It's right before we left. So now, this 50 million people in Korea, we found a different set of data. So this is the average amount of money in USD spent at a convenience store. Convenience store. Okay, so we recorded it 50 million data points last month. Average is $19. And then let's just say the standard deviation is about $3. However, you plot this 50 data points, it looks like this. Okay, so you can already tell this is not a normal distribution. So we can't do this thing, finding the z-score, because we don't have a chart that tells us the distribution. So maybe this is 20% and this is 20%. We don't know what it looks like. So that's what we need to use what we did before. We can still have the average and the standard deviation based on a non-standard distribution. But what we need to do now is we have to select different samples. So for example, this is still the same sample over here. I'm going to move it over here. So we now have to do the sampling distribution of the sample average. What does that mean? It means that now I pick 30 of these points. So some people spend $10, some people spend $20, some people spend $25. I pick 20 points. Out of these 20 points, it's going to have an average. So the average, we do sample size of 30. We pick 30 points out of the same population, right? And then now this forms an average. If you do that multiple times, but the beautiful thing is that you don't have to do it multiple times. If you do it once, you can forcibly create a sampling distribution of the little averages, because this average could be maybe not 19, but maybe 18. But this average could be 21, and this average could be 17, but it doesn't matter. With this, if we create 1 million data points, it will become normal. That's the central limiting theorem. So now, what do we know about this thing? We're interested about this because this tells us something. We can use these things, right? This one we cannot, so we have to create one. So this average is going to be the same as this, and then we're going to write it as the average of the little averages. Average of the little averages. So that is going to be 19, same as this one. That's what the theory tells you. And the standard deviation of that, of this thing, the standard, the sampling distribution of the sample means will have a standard deviation. And how do we find that? That is, take the original, this one, which is 3, divided by the sample size, which is 30. I actually calculated beforehand. It's 0.55. Now, with this, we can actually do a lot of stuff. I mean, just like any stuff. So now let's just say that there is a convenience store. I mean, there is one right underneath KIS. And then over there, they took a sample of 30. And then they found in the sample size of 30, in the one below KIS, that store, on average, people only spend $15. So now, so it's right over here. 15, 19, this is 15. So we want to find what is its percentile. So very easy. Let's first find the z-score. 15 minus 19 divided by 0.55. This number I also calculated beforehand. Negative 7.27. So this is a number that is a z-score that is really, really far from the average. So the probability of the z-score that is less than or equal to negative 7.27 is practically 0. So it's right here. It's at the 0 percentile. Now, if you randomly choose a store out of this many, many million, you pick that one. You pick the KIS one underneath. It's very unlikely you'll pick that one because most of them will be very, very near the average. So it means that maybe this KIS store that is below KIS, that store is not doing very well in comparison to all the other. It does not have the average of 19. Very unlikely it will have an average of 19. So this is the sampling distribution. This is the sampling distribution of the little averages. It's very important. Okay, let's do one more, and then we'll be finished. So now, same thing. Sample size, large N equals to 50 million people in Korea. This time, there are 50 data points. Let's just say that 50 data points last month. There were 50 data points last month. And then the 50 data points of people who went to a convenience store and bought Shin ramen, ramen noodles, right? So out of 50 million people, 7% of the people went in the store, they bought, they went into the convenience stores, bought Shin ramen. So now, as you can see that this one are little averages, but this one is a proportion, okay? So what does that mean? The distribution of this 50 million, it will be 7% bought Shin ramen, 93% of the people didn't buy Shin ramen. So you can see that this is not a normal distribution. So there's nothing we can do about it. But we can force one by creating the sampling distribution of the sample proportion. What makes it of the sample proportion? The same thing, 50 million data points, 7% of them bought Shin ramen. So I'm sure you can figure out, 50 mil times 7% equals to like a certain amount of people. That doesn't matter. We don't care about that. That's not the percent of people who bought Shin ramen. That's all we care about. Okay, so you can start doing little proportions. So now we're going to do a sample size of 200. There's a reason. There are conditions that need to be met. So the number that I'm choosing are the conditions. So we'll talk about it after. So now we do little sample sizes of 20. So it's about 200. Out of this 200, this group, it will have a proportion. This is large P, big P, probability of the population, 7% bought Shin ramen. And then P hat, in this 200, that just say 8% bought Shin ramen. They just randomly sampled 200 people out of this 50 million. And in this one, maybe 6.8%. It doesn't matter. You do that a billion times. Then now, this distribution will be transformed. We will force of these little proportions into a sampling distribution of the sample proportion. Okay, so this average will also be 7%, or 0.07, of course. What is this standard deviation? There's a formula. This is the average of the proportions, average of the proportion, standard deviation of the proportions. It would be square root of P bracket 1 minus P over the sample size, which is 200. So it's going to be, please don't write 7 times 93. Don't do that. You have to write 7% times 0.93 divided by sample size of 200. And I also calculated this number beforehand. It becomes 0.018. So that is the standard deviation of the sampling distribution of the sample proportion. What makes it of the proportion? Because these are all proportions, and we took these numbers and then we use a dot plot, and then it will form this thing. So now you can do the z-score and all that jazz. Remember, there's nothing you can do with the original given distributions if they're not normal. So you have to make one. So now really quickly, let's talk about the conditions and then we'll be done. The conditions of these is that you have to randomly pick 30 SRS. That's given. And then the second one is for the averages, the sample size that you pick has to be greater than or equal to 30, or if the original distribution is already normal. So, or normal distribution. We know that this one is not normal, so we use this one instead. And lastly, N has another, the third condition, N has to be less than or equal to this number, 10% of 50 million. Less than, so obviously 10% of 50 million is 5 million, and then 30 is less than that. So that means that you're unlikely to pick the same one. All right, now the conditions for this, same thing, SRS. And then the same thing for the third rule is that it has to be less than 10% of the sample size. There are 50 million, we only pick 200. 200 is way less than 10% of 50 million. But this one is slightly different. P times this 200 and 1 minus P times the N. They both have to be greater than or equal to 10 in order for this thing to form. Remember, hey, this has to happen, so a normal distribution will form. This has to happen, and this normal distribution will form. Okay, well, the review ends here.